Did you guys see that keynote intro?
It's pretty awesome.
It was good.
Michael Miller was badass.
Oh, I'd be scared to see that guy in a dark alley.
Terrifying.
Unless they thought they were back in college.
Yeah, imagine Neil's in the boardroom, man. He must be a tough cookie.
Yeah, for sure.
What about Thomas?
Hey, he's been working out.
Totally. Yeah. We can do something better for Demopalooza, though.
Oh,
yeah.
You gotta pull out the hair, man.
Yeah.
Oh, we need loud music.
Smoke.
Mirrors.
Tattoos.
Tattoos.
Yeah, it's got to be tattoos.
Inclement weather.
Oh, maybe dark, rainy shots with
Light.
glittering lights.
Yeah.
Oh, let's do it, guys.
Demopalooza. Demopalooza, man.
Thank you, everyone. Wow, that's loud. No one's prepared for how loud Aaron talks. Yeah. Welcome, everyone. Thanks for coming to Demopalooza. This week, we have been celebrating 25 years. And since SUSE has been around for 25 years, I wanted to spend a couple minutes to really think about who and what SUSE is. And the cool thing is, it's actually extremely easy, because I learned my first week when I joined SUSE. So I joined SUSE, in fact, I was talking to Cameron trying to figure out when this was. It was about 13 years ago. And I was lucky that on my first or second week at SUSE, I flew to Nuremberg and I got to meet with a whole bunch of engineers. And one of the first engineers that I sat down and I talked to, he explained to me that I do not work for an operating system company. He said, we don't do an operating system. What we are is we're a factory. We're a factory that runs processes, period. He said, right now we happen to make operating systems. In the future, we don't know what we're going to do, but we have just created a factory and processes that make it very, very easy to build things. And it was interesting, and I listened to him, and he started to explain to me about how things were configured and how they do builds and do tests. And understand, this was 13 years ago, right? And it was really stretching for me to understand what was going on. And we had a great conversation. He explained it to me, and it was cool. And I'm actually going to explain some of this to you in just a minute. But what's interesting is I was thinking about SUSE, and I was thinking about how they're 25 years old, and how it's really about process automation. I decided that is the only way that we can start out a talk about SUSE being 25 years old, is process automation. So then last night, I'm sitting backstage, probably about, Ralph, 10 o'clock last night, sitting back there with Ralph. Ralph was practicing for his keynote this morning. I'm getting ready to practice for our keynote as soon as Ralph goes off. And I'm just sitting there and go, Ralph, what are you going to talk about? And he goes, well, I'm going to talk about process automation. I'm going to talk about how we build things through a factory. I'm going to talk about how we do continually testing. And I just started to giggle. And Ralph's like, what are you laughing about? And I spun around and I showed him the slides that I was getting ready to show. And he's just like, oh, that's so funny. That's kind of what I was talking about. Because that's how ingrained this stuff is. This is really what SUSE does. So let me go ahead and explain to you what we do and how we build things at SUSE. So we're dealing with open source, right? And so the beautiful thing about open source is, to me, open source is presence, right? This is a package. This present may have come from us. It may have come internally. It may have come externally. It may have come from a cool thing that we want to join, a new open source project that's going on. But we've got this package. And now we want to bring it into the SUSE environment. So what are we going to do? So first, we've got our SUSE factory going. What's the first thing you notice about the SUSE factory? It's green, right? Even without the color, it's green, right? So we've got our factory. We've got this present. We've got this package that's going to come in. The first thing we're going to do is we're going to take that package and we're going to do some initial tests on it, right? We're going to make sure that it follows proper licensing. We're going to do all that initial thing, make sure the code's clean. But once it's passed all of those basic security stop gates, we're going to bring it into the factory. And what we're going to do to bring it into the factory is we're going to start to build that in a variety of different ways. First thing we're going to do is we're going to build it on a variety of different distribution methods, right? We're going to build it for an ISO, we're going to do it on drives, we're going to do it on hypervisors, we're going to do it on cloud, and now we're going to build things in containers as well, right? We've actually been doing this for a couple years. So I build in that package, I bring in that package, I build it on all these different platforms, and I make sure that it builds on all these different platforms. And what I'm actually doing is I'm doing a whole bunch of very, very cool tests. Like when we show the hard drives there, what we're actually talking about is running through hundreds of different configurations of, did that package affect when we install the operating system in RAID 1, 2, 3, 4, 5, 10, and everything? Does it get affected when we drop it out in this configuration in public cloud? Does it break when we do this configuration in OpenStack cloud, right? So we're testing a whole bunch of different things, all these different tests to make sure nothing breaks. And there's one key thing about this factory and this whole process. This is based on math and the scientific principle. The idea that if I'm using an equation and I put something in, I should always get the exact same result out, right? And that's the key that we're looking for. In fact, that's the key to this whole thing. We need to make sure that everything that comes in and is processed by the factory is completely reproducible. So we've got some packages in the factory. Let's talk about how we actually build an operating system. So now we just released SLES 12 SP3. Well, what did we actually do when we released SLES 12 SP3? What we did is we met with you guys, right? We met with our customers, we met with the community, and we looked at all those packages that we have available within our SUSE factory, right? Everything we've ever built, everything we could possibly want. And what we do is we go through and we hand-pick what we decide is enterprise grade, right? Code that is rock solid enough for you to run your business on. So we pick those packages, and only the ones that we will state our reputation on make it into that. So then we say, this is going to be SLES 12 SP3. So now what we do is we start on the process of testing, right? This is similar to what we were talking about before, where we're testing a whole bunch of different deployment mechanisms. Any way we could possibly think about installing the operating system, we're going to deploy it. But then something else kicks in, right? And that's our Q&A testing. We're using Open Q&A for all this. This is incredible. I got a chance to sit down and chat with the guys in Open QA, and it's amazing what this system does. It allows them to simulate any problem we have seen in the past, right? So we simulate users doing certain things that broke something. We simulate users trying out a website. We simulate people playing music. It runs through simulations of anything a user can do. So then, as those simulations are going, like let's say we're running through an install. It runs through the install. We're all used to this normal install screen. What will happen is, if a problem occurs, we'll get notified, and we'll say, you know, when you built this specific package on this OS, we saw on this screen, there was a 5% variance from what we were expecting to see versus what we saw. And that's what's cool, is it overlays what we were expecting to see on top of what we did see, and they literally have this slider that lets them slide it back and forth to see exactly what's changed. There was also a really cool thing that happened. You know, we've got the ability to play multimedia stuff in SUSE, so you can listen to audio and such. So we need some way to automatically test audio. So they have this music file that they always use for testing, and every time an OS is installed, it gets played, and they test and make sure everything's cool. So during the testing one time, somebody accidentally swapped out the actual album version of a song for a live recording of a song. What's cool is OpenQA ran through the test and came back and said, something weird's going on. These two MP3 files are 70% compatible, but 30% of it's not. And it's funny, it's when the musicians hit the notes right when they were playing, right? But isn't that amazing? It can see that type of variance in what's going on. So we do all of our testing. And this is what's cool. In talking to the QA guys, they told me how much beta calls have changed over the years, right? I used to be a product manager probably a decade and a half ago. One of the worst things was being on the beta calls when you got close to release time. He told me with SP3, it's the exact opposite. People aren't calling into the beta calls because there's nothing to complain about. There's a reason for that, though, right? The reason is when they're on those beta calls and we hear about a bug, the first thing the testing team does is they create a test to make sure that bug will never occur again, right? So we're always testing for that bug. So as soon as we hear about a problem, from here for eternity, we are always going to test for it, right? And this is why we can really scale and really do some cool things with our operating system. So we're continually enhancing that test suite. Now, remember, we're building SLES 12 SP3 not just for Intel, right? Because we're doing all those processes for Intel, but we're also doing them for System Z, for the P series, for ARM, and any other platform we decide to support in the future. And the cool thing is, because we've got all these automated testings, these things are always running. In fact, this factory runs 24 hours a day. It's constantly out there checking and updating and testing and making sure there's no problems. So that's the benefits that we, as SUSE, get out of the factory. The developer gets a couple additional things. And this is actually some of the things that Ralph talked about this morning. So, of course, the developer gets the ability to upload their package, get it compiled for 12 SP3 on x86, as well as all the other architectures they do. But when we do that, of course, we also do that for SP2, as well as 11 SP4, and Leap, right, and Tumbleweed. So this developer gets access to all those different operating systems, right? They can compile their app and make it available on all those platforms. But it's not just those platforms, is it? And again, as Ralph talked about it, we are very open and we very much are out there supporting communities. So what we do is we make it available for the developers to come out and build in a variety of different operating systems. These are the operating systems that are supported on the Open Build server. And it's great because the developer can really upload their code to one place and make it available to people however they want to consume it. But there is one key difference, right? What's the key difference between the stuff on the left and the stuff on the right? And it's really multi-year support. Or not multi-year support, multi-year caching of anything that's needed to build those operating systems. And it's back to what I talked about originally, right? Which is making sure it's reproducible. Because we support SLES 12 SP3, we're going to support that for SLES 11 SP4, we're going to support that for a total of 13 years. So for the next 13 years, we need to be able to go back in time and always have access to that original source code. So that's the key thing that we're doing there, is making that code always available, making sure it's always reproducible, and we can always get back to it. So that's cool. And that was really my first experience and introduction into this whole idea of doing continuous integration and continuous testing. But as we've seen and as you've heard about this week, this is really kind of a change in the industry, right? We're starting to see this. It's happening not just on the web front ends and on things like that. We're seeing them really have this integration, continuous patching, continuous testing is really becoming the norm. Did anybody read that article a week or two ago about Facebook, where they talked about Facebook updates their production systems 3 times a day? That's amazing. It's also incredible when you read the article because for testing, they test on just 1% of their user base, which is awesome when you realize 1% is like 60 million people, right? So it's pretty solid testing. But it's this whole new concept of being able to continuously test, continuously build, and continuously push out. Now, in order to do that, we really need to take advantage of some new technologies. What I'm going to do now is I'm going to spend the next couple minutes just leveling the playing field, making sure everybody's real familiar with containers and with Kubernetes before we start to show off and talk about some technology. So I'm just going to take a couple minutes so that we're all talking the same language. So, of course, we originally started with physical machines. We're all familiar with physical machines. We then went to virtualized hosts. We're familiar with those, where we've got a host operating system, a hypervisor, and then we've got a guest operating system running in there. The key thing with virtualization is I have a guest operating system running in every single one of my guest OSs, right? So here I've got the guest OS, library, apps, and binaries, and every time I bring up a new guest, it loads memory for the OS, for the applications, and for the binaries. And as you can see, it's using more resources every time I bring one up. Now, there's definitely cool things with virtualization. I'm a big fan of virtualization, does great things. One of my favorite things about it is those are isolated, right? I can be running Windows in one, SLES in another, various different versions of SLES. I can have any different operating systems that are supported by the processor running in there. So they're cool. However, they do take a lot of resources to run. And that's really where containers come in and give you a different way to build things. So with containers, I'm doing the opposite. Instead of starting with a full-blown operating system, I'm leveraging the operating system that's sitting on the host. So if we zoom in and take a look at that, I'm going to use a lot of the kernel that is sitting on that host operating system and really just use additional applications and binaries in that container. I can make that container very, very small and very, very lightweight. We can typically kick up a container in a matter of seconds, where, you know, a virtual machine, you're actually waiting for a full virtual machine to load. So I've got my container. And the nice thing about containers is they're very portable. It's very easy for me to take a container from one server, move it to another server, and make sure I get the exact same experience. And we'll talk about how that works in just a second. So really, the key to make a container work is you have to have a base operating system. In this case, we've got SLES, and you've got a container engine running on it. That might be something like Docker or Rocket. There's a variety of different container engines out there. So we've got a container engine running. And honestly, this is the key to containers. And it's not just the key to containers. You're going to find out that this slide can be applied to about 3 or 4 different things that I'm going to say today, because everybody's kind of going to the same architecture, right? And it's the same idea of, let's start with a manifest, right? Let's start with a document that defines whatever it is I'm building. In this case, it's a container. And if we start with that manifest and we build all of those identical containers off that one manifest, they're all going to be the same. All right? So I've got my manifest. In that manifest, it's going to define everything about this container. It's going to say what the base OS is. It's going to say any applications I want installed, any information it needs, you know, if it needs port 80 opened or what have you. That's all defined in that manifest. I then can simply tell SLES and that container engine to process that manifest. It will run it and turn it into an active running container on that server, right? And again, the nice thing is, since all of those containers are launched from a manifest, they're always exactly the same. So now if we update our manifest, the next time we relaunch those images, they're all going to be updated, right? It really gives me control. It's almost like having auto documentation, right? Because everything that's needed, we're forcing the people who are writing these containers to write it down, right? Put it in that manifest. And that's really the key to making this stuff replicatable. So containers are great. And in fact, containers are really cool when you're dealing with a single server, right? It's okay when you deal with a couple servers. But as soon as you start to deal with a bunch of containers and start to worry about the relationship and interrelationship between multiple containers, that's where you start to run into problems. So here we've got a container. We've got a host operating system running a container engine with some containers running. No problem. But as we start to add more, right, we start to hit into some admin headaches. Specifically, we hit headaches when we start to get, like I said, interdependencies in between connections, where we've got maybe a service that requires a web front end and a database back end. And really what starts to become a pain, how many of you guys have played with container engines and run into problems with like networking, right? Or scaling, or security, or figuring out how are you going to copy those manifest files in between all these different hosts? How are you going to automate everything? The bottom line idea of concepts of containers is fantastic. It's just the orchestration and the life cycle and stuff that gets really complicated. Luckily, there's a solution for that, right? And the solution is, like all good things, an open source project, right? Kubernetes. Kubernetes uses that same concept that we just talked about with a container engine of having a manifest. Let me go back for a second so you can see that. We've got a manifest for Kubernetes. So our manifest is going to describe a service or something that we want to provide to our customers. So it's first going to say, hey, you know what? We need a container that's got our front end, some sort of web server. It's going to put that in a Kubernetes pod. Then what we can do is we can say we need another pod that contains our database, our connection to our database, and maybe another container within that second pod that contains a service that's running our messaging bus to make sure everything is running smoothly and so we've got communication. So I get to define all of that and its relationship in that Kubernetes manifest. Then what I can do is I can tell Kubernetes, run this manifest and run it out on my Kubernetes cluster. And it's going to do everything it needs to get that service up and run properly, right? It's going to launch those 3 containers, get all the images down for it to run it locally on whatever host it happens to tell it to run on. It's going to set up that private networking in between it. It's going to let that service run. And then it's also going to tell Kubernetes that that service is available. So now I can go to Kubernetes, request that microservice, and it'll direct me right to that guy, right? So Kubernetes will say, this is where you've got that service running. But now I don't want just one version of this running. I want 4 copies of this running. So I tell Kubernetes, run 4 versions. It's going to go up and spin up 3 additional copies of that service and give me access to it just by talking directly to that Kubernetes service, right? It automatically redirects me to everywhere where those services are running. And then I, of course, can very easily just expand this out, connect it to the internet, and now my service is available to the cloud. It really makes it easy for me to deploy applications. What's the one thing that we didn't notice in that drawing when we talked about the distribution of these applications and everything? Do you see any servers? There are servers there, but to be honest with you, at this level, they're irrelevant to you, right? That's the idea behind Kubernetes. It's giving you a platform to do work on. You're just saying, here's the work that I need to do, here's how to go do it with those manifest files, and then you're handing it off to that. So with that, what I like to do is talk about one problem with Kubernetes, though, right? Kubernetes is fantastic. The underlying architecture is great. However, it's a pain to deploy. We're going to have Rob talk about that in just a minute. It takes time, takes a lot of knowledge and expertise to deploy Kubernetes. What we have with CAS platform, which we're going to show you in just a minute, is the ability to very quickly get up Kubernetes servers so that you can quickly get this environment so that you can do things. So we've got hardware. We then lay down a special version of SLES that's called Micro OS. It is specifically designed for this purpose of hosting Kubernetes. It's got a couple special features in it. One of them is it's got Salt directly in it, right? So that we can immediately communicate with it, make changes in configuration or anything we want. It also has a very unique way in which it's updated. These are updated transactionally. What I mean by that is the idea behind Kubernetes, like I said, is you don't need to worry about what server your application's running on. In order to do that, we need to make sure all servers are really running the same version of Kubernetes and everything. So what transactional updates allows us to do is to take a whole bunch of patches or changes or something you would do to a server and say a server either has all of these patches and changes applied or it doesn't. It's a 1 or 0 type thing. I say, put it on all these servers, it applies all of them. Does a rolling upgrade, all sorts of cool things. So I've got my micro OS. That gives me the reliability, make sure that those hosts are always healthy, and make sure that they're secure, right? That we haven't introduced any additional vulnerabilities. Then I'm going to put a container engine on it, and then I'm going to put on Kubernetes, right? So I've got a container engine, I've got Kubernetes, and now I can easily deploy applications. In fact, that's some of the things that we're going to show you right now. Rob, give us a look at what Kubernetes can do.
Erin, as you mentioned earlier, Kubernetes is...
Can we get the Mac pup, please?
Yep. Kubernetes is hard to install. Now, has anyone here ever tried installing upstream Kubernetes before on bare metal, for example? Yeah, got some hands up. I know I have, and it is a real pain. Even with some of the more modern tools, it can still take hours or days to get up and running, which is one of the motivators behind us creating and launching SUSECON platform, which gives you a really easy way to deploy containers either in your data center or your public or private cloud as well. So what I'm going to do now is walk through quickly bootstrapping and building a SUSECON platform cluster. Now, as it is at the moment, all I've done is installed what we call the administration node. There's 3 types of nodes in a SUSECON platform cluster. The administration node, which is the web UI you see behind me. A master node, which is our Kubernetes master, where the API is running and where we interface with the cluster. And a Kubernetes worker node as well, which is where your workloads actually run. So all we've done is installed the admin node, which during that installed micro OS and everything else that's needed, and created a user account and logged in. So the first thing that we've got to do is answer a very simple question. Where is our admin node located? What's the DNS entry for it? In this case, demo-admin. Now, we've got some other optional settings here that you can configure if you need to. For example, if you've got a proxy server in your environment, then you can configure that here. We don't, however. Once we click Next, we get a screen which can gives us instructions on how we can pixie boot other nodes. So it gives us an auto-yast file. And this is another thing that I really love about SUSECON platform, is it integrates seamlessly with your existing infrastructure using technologies that you already know. Some other Kubernetes implementations require you to learn new tools and new processes. We integrate with your existing DHCP and Pixie infrastructure, and I'm sure many of you are using AutoYast already. Now, we've already booted the worker and the master nodes for you. So we've booted our cluster nodes already, just so we're not sat here for 20 minutes watching packages install. Now, once we click Next, we get to this screen. Now, this is a really easy screen. We've got to choose which of our cluster nodes becomes our Kubernetes master. Again, this is where our Kubernetes core components run and the API runs, and we interface with the Kubernetes master, and which of our nodes become our worker nodes, where our workloads run. I'm going to select that one for master. It's also worth pointing out at this point that SUSECON Platform 2, one of the key highlights is that we've introduced Kubernetes multi-master, which is vital if you're running in a HA deployment. It's as simple as selecting more master nodes there. But for this environment, choosing 3 workers, 1 master. Now, once I click Next, there's one final question, which is, what is the address of the master node? Now, the API server is where our users interface with the cluster and where they point their client tools to interface with the cluster. The default value it's put in here is correct, so I'm going to go ahead and click Bootstrap Cluster. And now it's working its magic. What's happening behind the scenes is Salt is configuring all of the required services, settings, and configuration that's needed, starting all of the services for different Kubernetes components, making them all talk together. Now, this takes 2 or 3 minutes. So what we've done is we've already got a deployed cluster here, and this is what it looks like after deployment. So what we've just done is shown how in 3 to 4 minutes, aside from package installation time, that's how quick and easy it is to deploy with SUSE CAS platform. Okay, and that is a world apart from existing ways of deploying. So what I've done already is deployed the Kubernetes dashboard, and if we could get the PC up as well, side by side, and my trusty assistant, Kev, who clearly wasn't.
Come on.
Come on, let's do this. So
Don't be worried, Rob.
I'm just switching here to the cluster that's been built. At the moment, we've not deployed anything aside from an app called WeaveScope. Now, WeaveScope is an open source free application that can be used to give you some insight into your container infrastructure. And that's what's running on the left-hand side there. So at the moment, we've just got some basic pods, and these are some of the core components that CAS platform deploys that are needed for it to run. So what we're going to do is try deploying something to it.
Go on then. No more smoke and mirrors. Come on. Let's show them something real.
Now, I could go ahead and type all of the commands manually on the command line to deploy it. However, as Erin mentioned earlier on, we can put everything into a manifest file. And that's what we've got here. I've got a very simple manifest. What it's going to do is deploy Nginx. The top part here is just telling us what are we deploying, Nginx in this case, and where's it coming from, and how many instances of it will run. And at the bottom, we've got the services, which Erin was talking about earlier. How are we getting connectivity between our pods and between our different elements within our deployment? So what I'm going to do is go ahead and deploy that file. And what you'll see on the left-hand screen, on Kev's screen, is the Nginx container appear after a couple of seconds. Now, behind the scenes, what's happening is it's downloading that image from our private registry. We're running a private registry here because we want to keep our company data secure and not put it up in Docker Hub. And it's run that up and made that accessible, as you can see there. Now, all we've done here is just deployed Nginx. We've not put any content into Nginx. You know, you've got a full website, you know, that you're going to want to deploy. However, for containers, we need somewhere to store that data, and we need some persistent storage for all of that data. And Kubernetes has got us covered here. Now, Kubernetes supports numerous different storage backend plugins, and one of those is the Ceph plugin, which of course can be used with SUSE Enterprise Storage. Now, Kev here is going to give us a quick walkthrough of some of the new features available in SUSE Enterprise Storage 5.
All right, thanks, Rob. So if we can just get the Mac full screen, please, guys. Let me find the right screen. There we go. Look at that. Isn't that beautiful? Yeah? Woo! So this is the new interface for SUSE Enterprise Storage 5 that we announced earlier this week. Right, so this is the work the engineering team have been done, and as you can see, it's come a long way. We've now got a true heterogeneous management interface now for our storage solution. So let me give you a quick sort of harbor tour around what we can do in this. So as well as looking really pretty and beautiful, it also can do some useful stuff as well. So lots of squiggly lines, right? But you can actually drill into this and note all the graphs update dynamically, giving you a nice overview of what's happening on your cluster. And Rob's got really sweaty hands and the mouse doesn't work anymore. There you go. All right. So as well as just an overview, we can actually drill down into individual things. So we can click on, thanks. Anyway. We can look at individual things. So this gives us individual status on the node. So these are the actual cluster nodes themselves. If I click the right button, it may help. Let me just change back to that, and back to that. And let me click the right tab. And again, we just can click anything within the cluster again, whatever data you want. So fantastic, right? So you can get an easy snapshot of the overview of your storage cluster. So let's have a look at a couple of other things. So let's have a look at the OSDs. So OSDs are essentially the drives within your system. And you can see we've got 192 in there. So again, we can click down and get information about individual drives. So while that graph's loading, let me just point out BlueStore. So Blue Store is our new storage backend. This is a thing that under certain write situations, we can get 200% performance increase. So again, tremendous enhancement to SUSE Enterprise Storage. The people out there who've already got SUSE Enterprise Storage previous versions, which have file store on, you can actually do an in-place migration to that. So no more forklift upgrades to get the latest features and functionality of the product. Okay, let me just walk through a couple of other things. So we're going to have a quick look at pools. Now, what a pool is a pool is a, if you like, a representation of the OSDs where you can then do things with. So let me just go through that a bit. So I'm going to click on this, and I'm just going to make a nice, lovely graph appear. But let me just look at this in a bit more detail. So SUSE Enterprise Storage is fantastic for certain use cases, whether that's backup and archive. And again, we have multiple access methods to this. So RGW is Rados Gateway. That presents object storage to your subsystem, to your endpoints. We also have RDB, which is the ability to present a block storage out. And we also have CephFS. So CephFS is exposing a file system, so you can think of this as a NAS. Now, these three types of access methods are fully supported by us and production ready. Also, something new as well with SUSE Enterprise Storage 5 is the ability to do compression as well, right? So we can have compression built into the system as well. Spare me a sec while I get rid of Rob's sweat. Anyway. So as well as being a lovely monitoring interface, we can also do management with it as well. So if we can drill down, we can actually do configuration changes within this interface as well. And this is actually using our underlying deep sea technology with SUSE Enterprise Storage 5. So another couple of great use cases, and again, can now be fully configured via the interface or NFS, as well as iSCSI. And we're seeing a tremendous pickup with iSCSI, giving you ability to use things like VMware and Hyper-V to access all the benefits of SUSE Enterprise Storage 5. So in that, a really quick sort of overview, but you know, it's the place to come for if you want a highly scalable subsystem, extremely cost-effective, and extremely reliable. So with that, that's SUSE Enterprise Storage 5. Go and try it out. Okay, so if we can get both screens back up, that'll be great, guys. Yep. Thank you very much.
So, going back to where we were just now, we deployed Nginx, we bootstrapped a SUSE CAS Platform 2 cluster, and Kev just gave us a walkthrough of SES, which is our persistent storage for our containers. Let's try and deploy something a little bit more useful, shall we say.
Let's get in the fast lane. Come on.
The fast lane. How fast?
As fast as you want to go, baby. I'm ready. Come on. These young kids can't keep up. Come on.
So what we've done is we've built a microservice architectured solution, which we're going to go and deploy into our cluster now. Now, just to reiterate, one of the main benefits of microservices is we've decomposed our application into its individual components. So what I've got up here on the screen now is Jenkins. And for those unaware, Jenkins is a CI and CD tool that can do a lot of things. In this list here, we've got all of the individual builds for each one of our individual microservices. There's about 12 or 13 in all in different languages. We've got some Java, we've got some Go in there. And on this view, I have an individual job that I can click to deploy all of these to the Kubernetes cluster. So, in a couple of seconds, we'll see all of that start to kick off on Kev's screen. And again, what's happening in the background, it's pulling all of those containers from our private registry, spinning them up, creating the services and links between them. While it's doing that, I just want to point out one of the benefits of microservices. If done correctly, as we have in this deployment.
The rehearsing work, man, don't we? Come on.
To give an example, we've got a user service, stores usernames, passwords, addresses, Kev's credit card details, and everything else about a person. That has a database. Now, it's highly likely that the user service, because it's a tiny little Java app, is going to start long before the database is there or ready for it. In that case, all that's going to happen in this is that the user service will fail gracefully and keep retrying. It won't be a hard fail. We won't lose half of our website just because one little component within it has failed. And that's a key difference between some of the free tier or monolithic ways of application architecture. Right. So should we see how well built it was if I refresh the page here? To give it a couple more seconds.
You didn't talk long enough, Rob.
No, I didn't. So what's happened here is we've got our front end, and our front end is up and running already. But one of the back-end services, most likely the catalog service, isn't yet up and ready. So as soon as that is, then we'll have it available. But what I'll also do, just to be on the safe side, is just kick off a manual deployment, because everything's separated out, so I can do it step by step of the catalog service.
And all this bit was fully rehearsed, by the way, as well.
And it worked. So we'll just give that a few seconds. Have you got the catalog service on your screen there, Kev?
I don't know, it's so small. Just give me a second. What do you want?
So we've got catalog, and there should be catalog DB
Catalog
as well.
DB's up there, yeah.
There we go.
Yay.
Come on! Woo! If that wouldn't have worked.
I know, the rest of the keynote is based on this. So I think we just gave Aaron a bit of a heart attack, didn't we?
No idea.
But that's the joy of microservices, is that other parts of this application were still working even though my catalog was down. I may not have been able to browse my products, but I still would have been able to log in. And I'm not sure what use that is, but the point is as a user, I didn't get an unavailable error. I didn't get a 500. I didn't get service unavailable.
No, exactly.
And that's what's important.
Exactly. It just shows a single thing doesn't fail. It's agile, different life cycles, everything.
Absolutely.
So come on, let's see it in action.
So I'm going to log in. So as soon as I log in, all that's doing is talking to the user service, going off to the database, and authenticating me. I'm just going to have a little browse around the shop. So let's have a look in everything else. So, ooh, little green chameleon, because I haven't got enough of those already at home.
No,
but
you can never get enough.
You can never get enough. And Kent was just telling me how these things are flying off the shelves. They're going like hotcakes.
Yeah, they're walking off the shelves.
Walking, yeah. So I'm going to add this to my trolley. What this has now done is sent a message off to the cart service.
Right.
Yep. And then added it into my basket. There we go. What I'm going to do now is hit purchase. It's already got my address and my Kev's payment details already saved.
It's only $3.49, you're all right.
$3.49, you sure?
Yeah.
Sure, okay.
Yeah.
Cool. So I hit purchase, and immediately that's gone off and ordered. What's that?
Hey, Aaron, do you want to go and see what's going on?
Sure.
And while Aaron's over there, let's see what else we got in here, man.
Why, thank you, nice, kind delivery person. The key thing to microservices we really want to get out is we
Want
could...
a beer, Jeff? Want a beer? Cam?
Yeah, sure.
We could have at any point updated the shipping method. We could have swapped out the entire module, that entire microservice that would have run the shipping thing. We can swap it out, and it doesn't bring...
Should I just go get it?
Shh, keep it quiet. I'm trying to talk.
Oh, what's that?
Oh, you gotta be kidding. I guess I can't complain when it's my VP delivering the beer.
I think we need to see if there's a bottle opener on the shop, though.
Oh, that's hilarious. So, Kev, dude,
yes, mate.
Totally unfair. No way you can do that.
Yeah, can we just have the Mac up now, full screen?
We're okay, Rob. Don't worry about it. We're good. We're good.
What do you guys think? Do we need a scaling test? Yeah! Kev, let's see if we can make this thing scale.
How many?
1,000.
Yeah, is that going to be enough?
Yeah.
You sure? Okay. More. Hey. Good time. So here we go. We've got
What's
1,000.
a trolley?
A trolley.
What's a trolley? Well, it's a British
cart,
designer,
man.
British microservice.
Cart.
It's shopping cart.
Just purchase the damn beer.
Do you want to press it? Do you want to press it? Are you sure? All right, go on then.
That's, yeah, the people with the beer come in.
Come on, people with the beer. Here we go. Right, we go. Music's on, we go off stage, right?
So we're going to give you guys a couple minutes. They're going to bring you some beer. We're going to play a video, give you a little break, and then we'll come back out and show you some more stuff. But it'll be better because you'll have beer.
I'll look after these. All right, okay.
Hey. Do, do, do.
You could bring the tray,
Is
I
the
guess.
mic on?
Bringing Linux to the masses. Building sleds with open sources. Bringing Linux to the masses. Building sleds with open sources. Bringing Linux to the masses. Building sleds with open sources. Bringing Linux to the masses. Coding in the name of. Coding in the name of. And push my changes to GitHub. Push my changes to GitHub. Push my changes to GitHub. And push my changes to GitHub. And push my changes to GitHub. Push my changes to GitHub. And push my changes to GitHub. 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 And push my changes to GitHub. And push my changes to GitHub. Those who try, push changes wide. Use OBS to put the package inside. Give it a try, put it inside. Use OBS, spread the changes wide. Those who try, push changes wide. Use OBS to put the package inside. Give it a try, put it inside. Use OBS to spread the changes wide. Building sleds to open sources. Bringing Linux to the masses. Building sleds with open sources. Bringing Linux to the masses. Building sleds with open sources. Bringing Linux to the masses. Building sleds with open sources. Bringing Linux to the masses. Coding in the name of. Coding in the name of. Then push my changes to GitHub. Push my changes to GitHub. Push my changes to GitHub. Then push my changes to GitHub. And push my changes to GitHub. Now you control your code. Push my changes to GitHub. Now you control your code. Push my changes to GitHub. Now you control your code. Push my changes to GitHub. Now you control your code. Push my changes to GitHub. Now you control your code. Push my changes to GitHub. Now you control your code. Push my changes to GitHub. Now you control your code. Push my changes to GitHub. Those who try, push changes wide. Use OBS to put the package inside. Give it a try, put it inside. Use OBS to spread the changes wide. Those who try, push changes wide. Use OBS to put the package inside. Those who try, put it inside. Use OBS to put the changes wide. Come on! Come on! SUSECON's all built for no downtime. 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 Administrators!
No, but demoing. Demoing.
Ah.
Yeah.
All right, so I have to start out with what I think, and well, not what I think, but people who know me personally are going to think one of the most impressive things of the Demopalooza, and it has nothing to do with technology or anything. Do you guys notice something? Aaron's not in a black shirt, right? So you saw Michael Miller deliver the beer. That was literally the deal, right? I could drink beer on stage, provided at some point I wore a green shirt. So I just want, Michael, I met your commitment. So we've been talking about continuous integration. We've been talking about continuous development. We've been talking about, quickly making changes to the system, right? And that's awesome. And as an end user, I love it, right? I love the fact that I get new features all the time and I don't have to wait for features. However, there's some scary stuff with that, right? I get nervous about things like security, about vulnerability, and about patches. And in fact, that's the world where Jeff lives, right? Jeff is one of our resident SUSE manager experts. So Jeff, I'd really like to get your view on a bunch of these containers. What makes you nervous about it? What makes you excited?
I think the thing that makes me the most nervous is Rob.
but
other than
keep
that,
talking for a minute. I left my beer on the other side of the stage.
Definitely want
Do you need your screen up,
that.
Jeff?
So I guess, yeah, I think I could take
Can we
the
get the PC up,
up on the screen here. Say bye to Cameron.
They've obviously been drinking the beer as well.
Did you see how quick I got my beverage on the other side of it?
It's taking a while. The PC, can we get the PC on the screen?
Yeah.
There we go. Thank you. All right, so this is a PC. No, I'm just kidding. So, how many of you guys use SUSE Manager already? Okay. Let me ask you another question. Is there any SAP customers here as well? Okay, so how many people use SAP and SUSE Manager together?
Yeah, cool.
Okay, so I will just tell you, if you use SAP, SUSE Manager is a really good idea. I just want to kind of show you some of the channels that I do.
Cool.
A lot of my customers that I go and visit, SAP customers love SUSE Manager because they can set up their channels to do SAP patch lifecycle management and move their patches through their landscapes, their SAP landscapes, very efficiently. That, along with live patching, is kind of a godsend for SAP because now you've got the best of all worlds. You can actually do your patches from dev to QA to production, also live patches so that you don't have to reboot. So kind of it's just call it a trifecta. It could be a quadfecta. It could be any one of those. That's tough to say. So anyway, just wanted to talk about that. Has anybody installed, upgraded to the newest SUSE Manager?
Yeah,
okay. All right, cool. So this is an enhanced version of the newest SUSE Manager, some updates that are coming soon. We've talked a lot about containers, container engines, the management of that. So to your point, what scares me is not the development side of the house. It's about making sure that the development, once it's deployed to production in a production environment, that you have visibility about its compliance, its security, and visibility into when it isn't, and how to make it so. So some of the things that we've enhanced with the UI, other than it being adaptive, and I'm sure you'll hear Don say woohoo once in a while here, is the ability to actually take this reactive interface and actually get to the things you need right away. How many people have tried to search for things, and I know it's around here somewhere. This gives you the ability to kind of get to things really quick. So, for example, if I wanted to see one of the newer features like visualization, I can just start typing, and it starts to modify the menu right away, so I can get right to visualization. You can hit these target buttons, and that's really taking the menu and saying, okay, that's a section menu. So you can go right to a target. You'll know, hey, that's the top of a particular menu section, and it'll bring you into that new thing. So yeah, we've got, remember, when you were really fascinated by kind of the ragdoll effect
yeah, I love
in
that.
the SUSE OpenStack Cloud. So we've got kind of that same kind of thing where we've got visualization into the pieces and parts, whether it be a virtualization host or groups, the ability to kind of break down into different subsections by what we used to do, the system set manager and everything else. You can actually break and partition your groups and see them visually. So if you have SUSE Manager proxies installed, you can get right to those. You can even group systems together and see where they're connected. So all of these things will allow you to kind of get into your systems, and by clicking on them, you can see a summary of their particular update worthiness. So some other things around, I guess, the UI that are pretty cool, other than it being really, really fast. I don't know if you see.
Oh yeah, I noticed how snappy it is.
Some other things that we want to talk about, again, Rob was, been talking about containers. In here, we also have the ability to kind of look into some virtual host managers. So visualizing those particular visualization, I guess, visualizing the visualizations, the particular virtualization hosts, it's kind of tough to say those together. We have a Kubernetes cluster here as well. So we can actually attach to a configuration, a cluster configuration, and see those hosts represented here and how they're actually laid out. So,
cool.
Some other virtual host managers that we have, you can actually look into a VMware right out of the API. So I can actually go into a VMware host and see machines that are propagated through that. Some of the things that we can do is actually do some containers and builds ourselves, hooking into various registries, investigating their contents for compliance as well. I can show you that. So let's scroll down to the images section. So I've actually taken, Rob was nice enough to put up a Git repo and put a Docker file up there, or a Docker file that has Apache in it. So I pointed to his particular store, his registry.
So just like we talked about before, that's one of those manifest files for a container that's going to describe everything that's needed to make that container run.
So we create a store or a connection to it. We create a build host or reference a build host. We can see the profiles that are stored for Apache, and we can go into that particular file, and we can even schedule a build of that and select a build host to do it. So I can pick this build host, schedule a build, and it will start building that directly. The other thing is investigating the compliance of a particular build, looking at the images that are deployed, and it will show you the status and whether updates are available for that. Of course, I'm feeding off of an updated resource and repo right now, so it's going to use the latest version to that package. If, for example, there were some updates in the meantime that's been deployed, those would then be, you'd be notified that those are out of date and can update that build again. So that fine line between DevOps, I'm doing all this rapid agile development, I've got my own registries, I've got my own build environments, now I want to transition over to a production environment. The production environment can then say, here are the rules around compliance, and we can then pull from that registry and push to a production registry and do all of those things, intermingling, again, giving that DevOps. We can all work together once again. So
the key thing there is Rob is creating that Docker file, right? He's doing everything he needs to make his application run right. And then all you're doing is pulling that Docker file and checking it, spinning it up, and making sure it's compliant, making sure it doesn't have any vulnerabilities or any policies that you've put in place within your organization that you want him to comply with.
Are there policies that I want Rob to comply with?
There are plenty of policies that I want Rob to comply with, but we're specifically talking about
Okay.
computers now.
All right. I was going to say, first you go, just hike the shorts up a bit. But we can...
We're standing behind him on the
Right.
podium. It's
Millennials. Anyway, patches and runtimes right now, like I said, I built this off of a recent registry that had all the updates. So it's build right now.
Yeah.
You know, the rules I have definitely for my environment are this must be compliant and up to the latest and greatest patch sets. So I guess as we start to move and update our own containers and have a you know, bigger and brighter story around all of these container options and opportunities, it's nice to know that we're taking our technology, whether it's storage and the integration of salt and the states around all of that, and being able to kind of build them together, just like the rest of the development story that SUSE has had a long heritage.
cool. So it's really just expanding what SUSE Manager can do to just take advantage of a new delivery mechanism, right? Or
Correct.
new ways spinning up workloads.
Right, so if you think about it in the conventional sense, right, we've had this paradigm of package management, patch management, now we're getting into image management, container management, and SUSE Manager is becoming more of a manager of these things every day.
Sweet. So that's awesome. So thanks a lot for showing us SUSE Manager, Jeff. So, woohoo!
As they say, Aaron, and that's how we do it.
So everything we've talked about today, though, is very infrastructure focused, right? This is the stuff that we're used to. This is the type of conversations we always have. What we want to do now, though, is we're going to have a slightly different focus. So I need you guys to come up here for a minute.
Oh, sorry.
And we need to, yeah, Kev, if you could pay attention, focus up here. Yeah.
Keeps doing that.
Yeah, that's all.
What we need to do is we're going to have a quick scene change, right? Because this is going to be a totally different environment that we're going to come back from, all right? So these are going to be different people, different everything. So if we could prepare our scene change. Ready? Thank God, back to black. Kev, tattooed Kevin. Woo! Okay, so now we need to, if I could have my slides up top for a minute. I think I broke out sweating just not from having black on. Okay, so in this new environment, we are 100% focused on one thing, our end user and our developer, right? We are now in a game company, right? Our game company has one goal, and that is to deliver the best gaming experiences to its end user, right? To constantly provide new experiences and new games. And that's really our focus. And in fact, that's what we're going to do in this, is we're going to focus on the developer. And that's exactly what Cloud Application Platform does. It allows the developer to first look at something that we've got called build packs, right? And what these build packs do is they really contain all the information the developer needs to build their application. So here I've got a variety of different languages. You see common ones, Java, Go, Node, we've got Ruby, we've got Python, we've got .NET, and we've also got the ability to serve up static HTML web pages and things. So what happens is we bring Cloud Application Platform into your environment. And it really sets everything up for the developer to have the best experience they can have. So the first thing that's going to happen is the developer is going to pick their language, right? In our example, Kevin's going to be our developer, so he purely picked the language based on the logo, right? Nice, cute logo that Kevin would want on his laptop. If you know Kevin, you have, it is so close to the truth, right? So again, our goal is to get this application in the hands of our end users as quick and as easy as possible. So he's going to select, we're going to make it very easy for him to select his language. We're going to make it very easy for him to do common things that he wants to do in his application. User-based authentication within his application, as well as who can help him actually develop this app. It's also going to give him access to things like persistent storage, right? He's going to want to be able to store stuff within the game that he's writing. He's also going to want to be able to scale. To me, this is one of those funny things about the computer industry, right? So we're writing a game, the gamers are building the game, we go to roll out the game, and we let the IT department decide how to scale the application and how popular the game's going to be. Those guys don't know anything about the game. Who knows about the game? The person who's writing the game and the PM on the game, right? The people who have done all the marketing researches. They're the people that know what kind of scale they need at launch. It's also that developer that knows which modules are incredibly important and he needs to have fault tolerance on, right? So what we do is we make it super, super easy for this developer to just sit down, not worry about all that infrastructure stuff, and just code. Easily plug into these existing modules that the company set up, and then really just worry about the life cycle of that application, right? Code, test, push into production. Code, test, push into production. That's really what cloud application platform is about. Is it about making it so it's very developer focused, we can get that application out and we can get it to the end users, because that's really our goal, right? Get great games in those end users' hands. And of course, the great thing about CAP is I can take this environment and I can really drop it in anything, right? It doesn't matter what you've got. If you got bare metal, we'll drop on bare metal. We'll go into your hypervisor environment or your existing cloud or a public cloud. It doesn't matter. So what I'm going to do now is I'm going to ask Cam and Kev to actually give us an example of what we can do in this environment.
All right. So if you can get both screens up, please.
Both screens.
Okay.
I got to stretch out now because I've been sitting and watching all
Yeah,
this.
exactly. You've been primed, ready to go. And now's your chance to shine. So let me just explain what we have on the screen. So it may be a bit of a hard stretch, but I'm the developer, right? So I've got the developer screen here, and Cam's our ops guy, and he's got our new Stratos interface into Cloud Application Platform. So let me just show you what I've got here. So this is my, I've pulled my game down from Git, and I have it sitting here locally, and I'm just gonna push my application. So I want you, when not to press enter, which I've done, just watch Cameron's screen over there, and you'll, remember you got to refresh it, dude.
Oh. Yes, I do.
Yeah. So he's only just waking up. He's been over there for so long in hibernation. So what you'll see is, as the application's deploying, you'll see the application pop up on the screen.
Maybe. Shoo.
These Windows users, man.
Tell you what. Where'd it go?
Let's go again.
You're not Googling it, are you? Oh.
No.
What to do if your Keynote stops working?
So according to this, it's up, running, and live.
See if I can
get to it on my phone.
Okay, so look, while Cam's fixing that, let me just explain what we've done. We've created an application, and it's called Dizzy Lizard. Okay, so this is our app, and we've just pushed it, and it'll be running up on the cluster in a minute. So what I want to do is I actually want to go in and make some modifications to our application. Oh, here we go.
Whew.
Right, good recovery, Cam.
We
hey,
have
come
it.
on.
We have it.
Come
Dizzy
on.
Lizard.
Yeah, where's my beer? I was running out of things to say then, Cam. Good job.
Oh.
I can see the product team. They
It's
look very
because it's
resilient.
Windows.
Hey, it doesn't ship till
It's
later on
Windows,
in the
man.
year.
Wait. So I want to show you a couple of things in here. If we go and look at this cloud, we can actually see the entire the entire cluster. Well, maybe we can.
Huh?
Wow.
Windows.
Windows.
Have you tried turning it off and on again?
Yeah. How about
Something
rebooting
is-
it, Cam?
Something's gone wrong with our endpoint.
The internet at this hotel went down? No.
No way.
No.
Can we just play the game, Cam?
All right.
Right, one more go.
One more go of it.
One more go.
You can do it, Cam.
No pressure, no pressure.
No pressure. Hey, Rob, he might need some help. You come and stand over his shoulder as well. as well as 1,200 people in the audience, Cam. Streaming live to millions of people. Come on.
Come on.
You're doing it.
Being archived.
And then?
I can honestly say there's no one I would rather have than Cam in this position, though. if it's going to be fixed, Cam's going to do it. Otherwise, we're cool.
People. What bastards.
Wow.
Talk.
Yes. Isn't Prague beautiful, right? It's such a lovely city.
Architecture. Inclement weather.
Yeah, hoodies. Yeah. Slow walking. Right. Okay, so while Cam's hacking on that, and we'll get it up and running, let's imagine it's working, which I'm sure it is.
Oh, man. Oh.
Just launch the app. Hey!
Oh!
Woo! Cameron!
Just don't click too many buttons.
I guess what we learned here is that if you have too many Chrome browsers open, then the caching on this app might get a little bit messed up with Chrome.
Anyway, go.
So anyway, we have the cluster information up here for Cloud Foundry, for Cloud Application Platform. And you can see several different things in here. Aaron earlier was talking about build packs and how you can use those build packs to build your application. We can take a look at what those build packs are. Maybe? There we go.
Yeah. Yeah, every click is a round of applause.
So the build packs are various different languages that we can use to inject into our containers and build our application using that language. We can also take a look at our fire hose, which is kind of a neat feature. We can actually see what's going on.
That might be
the
useful,
logs
right?
and everything could be useful for debugging. We can enable and disable various things like the apps and counters and things within the cluster, and see what's going on in the cluster there. Might be nice for an ops guy.
Yeah.
Yeah.
Hey, yeah.
Absolutely.
Us devs love ops.
All right.
Let's get it working.
Absolutely. Dizzy Lizard's
Yeah, look at
there.
why don't we
Let's
show
see him
the hard
running.
work? Yeah.
Let's see him running.
Let's see my hard work. Right?
Let's go for it. Let's
Kev
look
Ops.
at Dizzy Lizard and let's just view the app.
Right, this is the most thing Cameron's rehearsed in the last 4 days. So let's see what's
I've been working really hard at
All right.
being ready to play this game.
Come on, see if you can get past the first one. Come on. Come on.
Hey!
Whoa! Look at him go.
That is the best.
Oh!
In the dry run, he crashed before hitting the first pipe.
I've been waiting to play video games all week.
All right, great. So I reckon this game's going to be pretty successful. So I think we need to modify it a bit. So why don't I make a few modifications to it? So it's our 25th birthday. So let me change this graphic a little bit. And as you can see, I'm also a pretty talented graphic designer as well as a developer. You know, I'm multi-talented. So we'll say, on a happy birthday.
I think it's more likely that Kev does most of his development in Macintosh's preview application.
Hey, it works. I don't know. Right. So I've modified my graphic, which is looking pretty good. I'm happy with that. So let me go to my my interface of choice. What's my IDE of choice? Yeah. Okay.
What is that, Adam?
This is Adam, yeah. So on here you'll see this is my clone of my Git. And with Cloud Foundry, we have a manifest. So a bit similar to what Aaron and that mentioned earlier, and Rob, is a manifest actually defines the parameters for the application. And we can
You're defining memory in disk quota. That's my job, isn't it? No,
don't worry.
step aside. This isn't. Step aside. Come on.
I've got it, Cam. Dev's got it, dude. You've got enough problems on that side of the wall, man.
Hey, look.
We love each other, really.
He gets tattoos and he gets tough.
Right. So let me make this 4 instances and let me just save that away.
Look, Kev.
What's that? Windows.
Yeah, dude. No.
No.
Check this out.
That looks like Windows to me. With a big chameleon on.
Are you lost, Cam?
I'm totally,
Cam,
I'm
look.
totally lost.
Look, go down
I am
here.
not a Windows
Press
guy.
this button here.
Oh, look.
Okay.
There's
That's
a
how you use
chameleon in there.
Windows, man.
Oh, we've got SLES 12 SP3. Wow. That's so cool.
That's running like a VM or something, is it? What's it doing? How's that working?
It's a container right there in Windows, I guess.
Okay, and how'd you
Oh.
get that container? Magic, or where does it come from?
I think there's a little SUSE shop thing over here.
A little shop? You mean the Microsoft shop?
Is that what it's called?
That's what it's called, yeah. Yeah.
Oh, the Microsoft shop.
Yeah.
That's right.
Yeah, yeah, yeah. We'll get there eventually, don't worry. Don't worry. All right.
You can explain this. Windows services for Linux or not?
Well, Cameron's meant to, but do you want to explain it?
No,
Just step up and do it, dude.
Right, anyway, back to me, because it's all about me. Right, so, right, I've got my changes over here, which I
Does
now...
it really need that much memory? Oh, okay, I guess so.
Do you want me to change the memory?
He's the developer, he knows.
Yeah, exactly. Right, so what I'm going to do now is I'm actually going to commit my change. So we'll do kevs, change, keynote.
This
right?
really is KevOps.
It is KevOps, right? Oh, I need to stage it, right, first. Right, and now I'm going to commit it. And there's a little button down here, which you may not be able to see, but let's do that. And I'm going to push it now. So what this is actually doing, it's taking my changes locally, and we're pushing it up to GitHub, because DizzyBird is actually open source, and we'll give you the URL later on. So
Dizzy
you can
Lizard.
Dizzy Lizard, what did I say?
Dizzy
You know,
Bird.
Dizzy Bird?
You should tell them. You should tell them. I mean, it's actually up live on GitHub right now.
It is,
Yeah.
yeah.
And,
Okay, and what, Rob?
and we're now the only ones with it after it stopped working on iOS 11.
Absolutely.
Yeah, there you go.
Right, so I've made the change, pushed up. What I need to now do is actually deploy that to our cloud application platform. So again, this is what I'm really good at, just hitting the button, right? So there you go. So
it's
what's
the
happening?
easy way.
Yeah, so we're uploading the files, and it's off and building. So Cam, why don't you show them what's going on?
All right, so back to the dashboard. Wow, that's really small.
Can we get the PC a bit bigger, please, guys?
Oh, he's almost built.
Hey! They're making you work for your money today, man.
Yeah. All right, so he's working on, he's upping his instances. While he's doing that, let's go ahead and take a look at this back to the cloud again. And in the cloud, you can actually, for the entire cluster, you can go ahead and create spaces. Let's go ahead and take a look at creating a space. Now, you might have, QA, you might have test within your organization. And so using a space is a good way to actually nail down some quota for that particular application that you're going to launch, such as disk quota and memory and things of that nature. So you can really, not let your application run amok on the system, especially those developers over here.
Right, so you don't really trust this is what you're saying, right?
That's right.
Okay, thanks.
Yeah.
Trust me, though, Cam, right?
I trust you.
Good man.
There's a lot of love here with DevOps, right?
Why don't you show us another way we can deploy it?
Oh, yeah.
Okay.
Let's take a look at that. You can actually, instead of actually having Kev do the easy button with the CF push command, we can actually go over to the web UI and deploy an application as well. We can select an organization, maybe. Cloud Foundry.
Doesn't matter.
There he is, QA. And then there's our dev space. We hit next.
Right,
and
we
then
can just put in all the same parameters.
Same
that we've got
parameters.
locked
We
in,
can
right?
publish the Git URL in there
Okay.
and hit deploy, and it will launch the same application.
So come on,
or an
Cam.
application.
My machine says Dizzy's up and live.
Dizzy's
So
up
why
and
don't we
live.
show them with my fantastic skills of graphic design and the
That's-
changes and what's happened?
That's awesome. Let's take a look. So we've got 4 instances there up and running, and you can see his usable disk and memory and his uptime. But more importantly, we can still hit our app. We can still see Dizzy running in the cloud.
And then, oh, that says text, so that didn't work.
Oh, text. You didn't push text.
I didn't save the file.
You didn't
I
save
didn't
the file.
save the file. The text
Can't
is
trust-
the default.
cannot trust the developers.
So this is good stuff, right?
What?
This is one of the slickest demos anyone's ever seen.
You know what's in here, right? And that's how you do kev ops, everyone.
Okay.
Hey, come on, play the game.
And that is a cloud application platform.
Oh.
So
There we go, back to
Failed
normal.
miserably.
can I continue? Are you done? Yeah.
No, I gotta try again.
They're all right, they got beer.
I better sit
He
down
crashed on the
before I-
first one again, didn't he? Yeah. So we've had a really fun week this week. Thanks for participating in everything throughout the week. Don't worry, we still have tomorrow. You're not leaving or anything, but we've had a great time. And one of the things that we want to do now is start to talk about some of the cool prizes that we're going to be giving away. Ooh, SUSECON prizes redefined. I can't even read this slide at this point,
This
right?
beer is good, isn't it?
It is really good. So, first, our prize winners. I am not going to read everybody's name, right? But how could you have won prizes? We had a ton of different ways. First, we had the contest that was going on in the casino. We had a developers quiz that was going on. We had the passport to prizes in the technology lab, where you got points for doing various things and interacting with people and seeing cool demos. The top winners are apparently these people that I should have not clicked on before I read all that stuff. So, surprise! I've had a lot on my mind. I'm sorry. So, yeah, you guys won a bunch of stuff, including some Nooks and, yeah, some other things. You can pick up your prizes when we are done, right? But we're not done, Kev.
No,
we
we're
got to
not.
have more stuff we can give away, don't we?
Sure, there's some more stuff, yeah.
So what else can we give away, Kev?
Can we get the Mac back up? So should we have a little look deeper into the shop? See what else we've got in there? So let's kick on catalog. Oh, what's this prizes thing? Ooh. So we've got socks.
Ooh.
Yes.
We've got webcams.
Ooh, Raspberry Pis.
Inclement weather.
Beers.
Yeah, so we've got some stuff, right, that we need to get rid of. So how are we going to do that, Aaron?
So actually, we're going to throw a bunch of the stuff up, but I got to tell the funny reason as to why we have extra Raspberry Pis and webcams and why we're going to give them out. That's because as we're packing up for the show, Kent gives me a call, and Kent's like, yeah, I'm going through this closet, and there's a whole bunch of stuff that you've had me buy for previous keynotes that you never wound up using. And I was like, oh, really? And he's like, yeah, what should I do with it all? I was like, just bring it. Let's freaking give it away, right? So let's go ahead, and Kent, are you going to bring out some of those things? Yay.
Let's go,
Kent,
man.
guys, come here.
Why don't we play a video, right, while we're giving this stuff out?
So, guys, come here, give some
Do it.
stuff out. We're gonna, I want a video to play, which is kind of the making, toss some of these stuff out. Now you're gonna find out why I spent all my life behind a computer and not playing. Oh, God!
She's gonna throw this.
There's one.
Yeah.
Yeah.
Aaron, wait for the video and then we'll walk around, man.
I had no idea it was gonna fly like that. if you've got a prize, come grab your prize. Otherwise, enjoy and have some beer with us outside.
And get your socks.
Yeah,
Oh yeah!
socks.
Oh yeah!
Socks
And
on the
those
way
of you
out.
who didn't win anything or didn't get hit when Aaron tried to throw things out in the audience, we also have 1,000 pair of socks to give away. So grab socks as you go away. Thanks a lot, and we'll see you
Thank
next
you,
year.
everyone.
All right.